In about 100,000 years, the constellation Orion will change shape as the bright star Betelgeuse is expected to explode in a supernova. When it happens, the explosion will be so bright that it could be visible from Earth during the day for weeks or even months. It might even outshine the full moon for a short time before fading away, forever altering the night sky. There are many more events like this that we will see in the future. In today's video, you will see 10 events that will happen after we leave. Number 10. In about 100,000 years, Earth is expected to enter a new ice age due to a combination of astronomical cycles, climate patterns and geological changes. In about 100,000 years, Earth will receive less solar energy at certain times. This weakens seasonal differences, allowing ice sheets to expand. As global temperatures drop, snow and ice stop melting in summer, allowing glaciers to grow. More ice reflects sunlight, further cooling the planet. Large ice sheets start expanding over North America, Europe, and Asia. Colder oceans absorb more CO2, reducing the greenhouse effect. Less plant life leads to lower atmospheric methane, further cooling the planet. Sea levels will drop by over 100 meters, exposing more land. Unless human technology intervenes or greenhouse gas emissions delay the process, this ice age could last tens of thousands of years before warming cycles return. Number 9. If Yellowstone supervolcano erupts 25,000 years from now, it would be likely a cataclysmic event with global consequences. A super eruption would reject over 1,000 cubic kilometers of magma, enough to bury entire state. Volcanic ash would blanket North America, covering cities in meters of debris. Superheated clouds of gas and rock would race at 300 plus miles per hour, destroying everything within 100 miles. If the explosion reaches nearby lakes, massive waves could flood surrounding regions. Ash and sulfur dioxide would spread in the atmosphere, blocking sunlight for years. Temperatures could drop 3 to 5 degrees Celsius or 5 to 9 degrees Fahrenheit, leading to crop failure and famines worldwide. Number 8. Asteroid 1950 DA has a chance of impacting Earth on March 16, 2880. The exact location is uncertain, but an ocean impact could cause massive tsunamis. If it landed on land, a crater would be 15 to 20 km or 9 to 12 miles wide. Firestorms, earthquakes, and atmospheric dust blocking sunlight. If dust enters the atmosphere, it could cool the planet for years. This asteroid spins so fast that its gravity alone shouldn't be able to hold it together, suggesting it's held together by weak cohesive forces like van der Waals forces, not just gravity. If this asteroid hits, the asteroid would explode with the force of about 50,000 megatons, about 1 million times the Hiroshima bomb. While it has the highest known probability of impact for any asteroid, it is still very unlikely to hit. Number 7. In about 600 million years, total solar eclipses on Earth will no longer be possible due to the moon's gradual drift away from Earth. The moon is slowly receding from Earth at a rate of 3.8 cm or 1.5 inches per year due to tidal interactions. Over millions of years, this will increase the moon's distance from Earth, reducing its apparent size in the sky. The sun is slowly growing larger as it burns through its hydrogen fuel. This will make the sun appear slightly bigger in the sky over long time scales. Astronomers estimated that in about 600 million years, the last ever total solar eclipse will occur. After that, only annular or partial eclipses will be possible, changing the way future Earthlings or any surviving life experience eclipses forever. Number 6. In about 800 million to 1 billion years, Earth's oxygen levels will drop drastically, leading to the extinction of most complex life forms. This will happen due to changes in the sun, Earth's atmosphere, and the carbon cycle. Over time, the sun's brightness increases by about 10% every billion years. This extra energy will intensify weathering of rocks, which absorb carbon dioxide from the atmosphere. Plants and algae use CO2 to produce oxygen through photosynthesis. As CO2 drops too low, plants will die off, cutting off Earth's main oxygen source. Humans and animals will die as oxygen becomes scarce. Oceans will shrink and become toxic, killing marine life. Only microbes adapted to low oxygen, such as anaerobic bacteria, will survive. Number 5. In about 5 billion years, the sun will enter its red giant phase, dramatically changing our solar system. The sun, having burned most of its hydrogen fuel, will start fusing helium into heavier elements. This will cause the sun's core to contract while its outer layers expand, making it 100,000 times larger than today. It will engulf Mercury and Venus first, and Earth's fate will be sealed soon after. As the sun grows, Earth's temperature will skyrocket, boiling away all oceans. The atmosphere will be stripped away, and the planet will become a dry, lifeless wasteland. The planet will melt and disintegrate within minutes, becoming part of the sun's outer shell. After the red giant phase, the sun will shed its outer layers, forming a beautiful planetary nebula. The sun remaining core will become a white dwarf, a small, hot dense remnant that will slowly fade for trillions of years. Number 4. After 1 trillion years, the universe will enter the degenerate area, where all stars will have either burned out or collapsed into remnants. The universe is expanding and new stars are forming more slowly. The smallest, longest living stars like red dwarfs will be the last to burn out, but even they will fade into black dwarfs, cold invisible remnants of former stars. With no new stars forming, the universe will be filled with black dwarfs, neutron stars or black holes. With no stars left, planets will become rogue holes, drifting along through the vast emptiness. With no heat sources left, the universe will reach absolute darkness and near absolute zero temperature. Number 3. After 1 quadrillion years and far beyond, black holes will slowly evaporate due to a process called Hawking radiation. Hawking radiation is a quantum process where particle-antiparticle pairs appear near the event horizon of a black hole. Over trillions of years, this causes the black hole to slowly shrink as it radiates away mass. When the black hole becomes incredibly small, about the size of an atom, it will release its remaining mass in a final burst of energy. This will be an immense gamma ray explosion, briefly shining like a star before disappearing completely. If no new black holes form, this marks the end of black holes in the universe. At this point, the universe will be dark and empty, with only cold, scattered particles drifting through the void. Number 2. After a global years, all black holes in the universe will have completely evaporated due to a process called Hawking radiation, leaving behind only weak radiation and subatomic particles in an empty universe. According to Stephen Hawking, black holes emit Hawking radiation, a slowly process where virtual particle pairs near the event horizon cause the black hole to lose mass. Over time, this radiation slowly drains the black hole's energy. With all black holes gone, the universe is left with only low-energy photons and neutrinos spread across an ever-expanding cosmos. Number 1. After 10 to the power 10150 years, the universe will experience its final stage, heat death, a state where no energy differences exist and no work or life is possible. With no more black holes, only low-energy photons, electrons, positrons, and neutrinos remains. Matter will decay into fundamental particles, leaving a thin gas of radiation. Entropy reaches its peak, meaning no more useful energy exists. The universe is now a uniform, featherless void of ultra-low energy photons. Even atomic particles may decay into nothingness, leaving pure radiation. The universe has expanded so much that everything is at the same temperature, just above absolute zero. No more energy transfer can happen, meaning no reactions, no motion, and no life. The cosmos becomes a cold, dark, eternal void where time itself becomes meaningless. We won't stay, that would be good. If you all love watching videos like this, then watch this video, a documentary about Jupiter. You will learn something about Jupiter that you didn't learn in school. Thank you.